Every single day, we're navigating a digital world that's just packed with hidden dangers. So today, we're going to pull back the curtain on those threats. We'll start with the kind of malware you've probably heard of, but we're going to end up showing you exactly how security experts think, so you can better protect your own digital life. So let's kick things off with a quick question. You've definitely heard of computer viruses, worms, and Trojans, right? But what do they all actually have in common? Well, they're all designed to cause some kind of digital chaos, and they all fall under one very specific umbrella term. And that term is malware. It's short for, you guessed it, malicious software. And it's really just the catch-all category for any code that's been specifically created to disrupt, damage, or get unauthorized access to a computer system. This idea is pretty much the foundation for everything we're talking about today. Okay, so here's our game plan. We'll start with the basics of what malware is. Then we'll dive into a whole arsenal of different attack types. From there, we'll look at a more subtle kind of threat called an injection attack, before we switch gears and look at how the pros think defensively and actually model threats to stay one step ahead. All right, section 1. What is malware? So we've just established that it's basically any software that's built to do harm. Now let's start breaking down all the different and sometimes creative forms it can take. And that brings us to section 2, an arsenal of attacks. It's time to meet the rogues gallery. These are the most common types of malware you're likely to hear about, or hopefully not, encounter. First up, the classic computer virus. Now, the critical thing to understand here is that a virus can't do anything on its own. It has to latch onto a legitimate program, like a parasite, and then it needs you to actually run that program to bring it to life. This reliance on a host is how it spreads, but it's also its biggest weakness. Next up, we have the worm. And unlike a virus, a worm is a standalone piece of software. It's notorious for its ability to copy itself and just spread across networks all on its own, usually by exploiting security holes to jump from one computer to the next. You know, the blaster worm back in the early 2000s was a perfect and very annoying example of this. It caused hundreds of thousands of PCs to just restart over and over again. So, if you're going to remember one thing, it's this. A virus is a parasite that needs a host file to survive, while a worm is an independent agent that travels the network completely on its own. It's the single biggest difference between the two. And then, of course, there's the Trojan horse, which is named after that ancient Greek story for a very good reason. This type of malware disguises itself as something you actually want. A game, a cool utility, maybe an important document, all to trick you into willingly letting it inside your digital walls. And once it's in, it can do all sorts of nasty things, like spy on you, steal your data, or open a backdoor for even more malware to sneak in. Now we're getting into a bit of a gray area with something called a potentially unwanted application, or PUA for short. Now, this stuff isn't always, overtly malicious, but it is software you definitely do not want. Think about the last time you installed a free app and it tried to sneak in a new browser toolbar or change your search engine. Yeah, that's usually a PUA at work. And within this PUA family, you find a few different flavors. There's adware, which just bombards you with pop-up ads. There's spyware, which, as the name suggests, secretly collects your information. And then there's scareware, which tries to frighten you with these fake virus warnings, all to get you to buy useless software. And finally, we get to one of the most destructive types out there, ransomware. This is digital extortion, pure and simple. Attackers get into a system, they encrypt all the files, making them totally useless, and then they demand a ransom payment to give you the key. The WannaCry attack back in 2017 was a massive wake-up call, crippling hospitals and huge businesses in over 150 countries. It really showed the world just how devastating this threat can be. Okay, section 3, web-based injection attacks. So far, we've mostly been talking about malicious files that you might download, but what about attacks that don't need a file at all? Well, that brings us to injection attacks, which cleverly exploit the code of the very websites and apps we use and trust every day. The core idea here is actually pretty simple, but it's incredibly powerful. Attackers find a weak spot in an application's code, a little crack, that allows them to inject their own commands. The application then runs this malicious code, thinking it's just a normal, legitimate part of its own programming. A huge example of this is SQL injection. So think of a website's database like a secure library, and SQL is the special language you use to ask the librarian for a book. Well, an attacker uses something like a website search bar to phrase a really tricky question that fools the librarian into handing over the keys to the entire restricted section, and just like that, they can get access to things like user passwords and credit card numbers. Another really common one is cross-site scripting, or XSS. Now, if SQL injection targets the website's database, XSS targets the website's visitors. Here, the attacker injects a malicious script into a totally legitimate web page. So when you visit that page, the script runs in your browser, and it can be used to steal your login cookies or other personal data right from under your nose. So that leads us to Section 4, how to think defensively. We've seen a whole bunch of attacks, so how do we fight back? The real key isn't just reacting to threats as they pop up. It's about building proactive, secure systems right from the very beginning. To stop these injection attacks, developers have to operate under one core principle: treat all user input as potentially hostile. They use techniques like input validation to make sure data is in the right format, like checking that a zip code field only contains numbers. They use input sanitization to literally strip out any dangerous-looking code. And they use something called prepared statements, which is kind of like giving the database a fill-in-the-blanks template so it can never confuse user data with an actual command. It's really all about building strong digital walls.
Okay, and that brings us to our final and most strategic section, modeling the threats. This is where security professionals really level up. They shift from just reacting to attacks to proactively thinking like an attacker in order to build much stronger defenses from the start. So what is threat modeling? It's basically a structured process. You look at what you're trying to protect, your assets, and then you systematically brainstorm all the possible ways it could be attacked. It is all about finding the weaknesses before the bad guys do. And this is not a one-and-done kind of thing. It's a continuous cycle. Teams figure out what they're protecting, they identify and analyze all the potential threats, they fix the biggest risks, and then they evaluate how well they did, before starting that whole process all over again, because new threats are always emerging. And this isn't just guesswork. It's a really mature discipline with a lot of established frameworks. I mean, big companies like Microsoft develop their own, called Stride, to categorize threats. Others like Pasta and Vast offer different approaches that are more risk-focused or even automated. The big takeaway here is that there are structured, professional ways to think about all this. But, despite all those complex frameworks and acronyms, threat modeling really just boils down to answering 4 simple but incredibly powerful questions. What are we working on? What can go wrong? What are we going to do about it? And finally, did we do a good job? And that's where we'll leave it. We've gone all the way from a simple computer virus to the complex strategic thinking of threat modeling. So I'll just leave you with this question. Now that you have a little glimpse into how the pros think, how does it change the way you look at the security of the apps that you rely on every single day?